concept of discount. We will look at what discount is, and we will look at what the rate of discount is. We will examine discounted values, how to convert between different rates of discount, nominal rates of discount, and we'll finish up with a basic example of a calculating using discount. Now, suppose that X is invested and after a period of time accumulates to amount Y. If B is the discount on Y given X, we write this expression. B, you can think of discount on as a relation that relates B on the one hand and Y and X on the other. Now, we will define B discount on YX is equal to B interest on XY. So in other words, if B is the discount on Y given X, then that is the same thing as saying that B is the interest on X given Y. Now, recalling that B interest on XY is equivalent to B is equal to Y minus X, we can see quite clearly that B discount on YX is equivalent to B equals Y minus X as well. Next, let's take a look at the discount rate. If let D be the discount rate, then the discount rate is related to Y and X by the expression D is equal to Y minus X over Y. If you can remember the interest rate, then you'll realize that was Y minus X over X. So you can see the difference. But we'll look at that a bit later on. Now we use the interest rate to calculate an expression for Y, which we call the accumulated value. Let's do the same thing, but this time we will use the discount rate to calculate an expression for X, which we call the discounted value. So let's start with, if D is the discount rate, then by the definition of discount rate, that's the same as saying that D is equal to Y minus X over Y. And if we shunt the Y, this Y to the left hand side, we get that D times Y is equal to Y minus X. If we shunt the Y to the left hand side, the second Y, we get that Y minus D times Y is equal to X. And if we factorize, we get 1 minus D times Y is equal to X. So we can see right there that given the accumulated value, to obtain the discounted value, we multiply by 1 minus D, where D is the discount rate. We will because the question 1 minus D pops up a lot, we will give it a name and we'll call it dfac.d. So using that name, we now see that dfac.d times Y is equal to X. Okay, so if we start with Y, and after one period of time, we will have Y times dfac over D. After 2 units of time, we will have Y times dfac over D squared. In general, after n units of time, we will have Y times dfac over D to the n. And I'm sure you can see how similar this is to when we're dealing with interest rates. We can thus define a function that, given the discount factor, okay, say an amount Y, gives the discounted amount after derived time units. And that's simple. We will call that function a bait, and we have a bait of k of derived Y is equal to Y times k to the power of derived. Very simple. Now, just as we can convert between rates of interest, we can also convert between rates of discount. So again, we will make use of the principle of consistency. I'm sorry, but here when it says fac of I and fac of j, it should really be d fac of I and d fac of j or something. But it's not a big deal. So, or really it should be, oh, I see what I've done here. I've used, oh, this slide is, okay, that should say discount and that should say discount and it should be D and Q. I'm sorry about that. Anyway, let's just follow through the calculation. let's suppose we have two different time units, one measured in y and measured in m, and we have that 1 times y, or 1y, is equal to pm's. So 1 y unit of time is equal to pm unit of time. For example, p could be 12, in which case, and y and m could be year and month respectively, in which case what we're saying is that 1 year would be equal to 12 months. Now, by the principle of consistency, that's the same thing as saying as d fact. This is not the same thing as saying, but implies that the d discount factor of d to the power of 1, remembering that d is a wily discount rate, is equal to d fact of q to the power of p, where q is a Emily discount rate. Now, by the definition of that should be d fact, that is 1 minus d to the 1 is equal to 1 minus q to the p. Then, if we shunt the p to the left hand side, we have this expression, 1 minus d to the 1 over p is equal to 1 minus q. And if we shunt the 1 again, we have the 1 minus d to the 1 over p is equal to q. So, given discount rate, wily discount rate d, this expression converts it into an Emily discount rate. And we apply the definition of d fact again, and we get that 1 minus d fact to the power of 1 over p is equal to q. This, of course, allows us to find a function dcast, p of d, which is equal, of course, to that same expression, 1 minus d fact of d to the power of 1 over p. Now again, just as we have nominal rates of interest, we have nominal rates of discount. And we see here that the nominal rate of discount will be per y compounded Emily. And we can define a function d nominal to convert an effective discount rate into a nominal discount rate, as follows. If p satisfies y equals p times m, then we can go from an Emily discount rate to a per y Emily discount rate by multiplying the discount rate by p. And we can also go the other way to convert an nominal discount rate to an effective discount rate. Again, we just divide our nominal discount rate by p, and that will give us, so if we have a nominal discount rate that is per y Emily, then we'll get a Emily discount rate by dividing by p. Okay. Now, we remember we had the force of interest. We also have the force of discount. Now, you might wonder what's the relationship between the force of interest and the force of discount, and the answer is we'll look at that in the next video. But for now, we'll just derive the force of discount in the same way we did the force of interest. That is by taking the limit as p tends to infinity. So remember that this d nominal p, dcast pd, is a nominal discount rate per its discount rate. And remember our expression for d nominal p of e is equal to e times p. So in this case, e is dcast pd. So this expression is the same as p times dcast of pd. And again, resorting to our expression for cast, we get that that's equivalent to p times 1 minus discount factor to the power of 1 over p. Now we resort to calculus, which tells us that the limit as p tends to infinity of p times 1 minus x to 1 over p is equal to negative ln of x. In this case, our x is d fact of d. Therefore, this entire expression, this limit, is equal to negative ln of d fact of d. So then we'll just introduce the force function, the d force function. And so if we have a discount rate d, to convert it to the force of discount, we just apply d force to it, where d force of d is equal to negative natural logarithm of d fact of d. Alright, now let's apply some of what we learned in the basic example. An investor who is liable to income tax at a rate of 40% receives a payment of £9,000. What is the net income received by the investor? Now, we can view the reduction of the gross income by tax as that should be abate over a single time unit. So, what we have to do is we have to calculate abate of d fac of d of do y, and now we just have to substitute the values we've been given in the question. Now, in this case, the discount rate is the same as the tax rate, the income tax rate, which is 40%. So d is 0.4. Yeah. As we said, we can view it as a single time unit. So that's do will be 1, and of course y is 9,000. So we reduce to this expression, because remember that 1 minus 0.4 is 0.6. Yeah, then the definition of abate gives us 900 times 0.6 to the power of 1, and we can easily calculate that. That's 5,400. Okay, so after tax, the investor will actually get £5,400. Wow, that's a big chunk of money goes into tax. All right, now let's just again, as it's become customary, we'll write a program to show these ideas in action. And so first we'll define the function dfac of d equals 1 minus d. Sorry, it should be let dfac of d, and then we have let abate k do y equals y times k to the power of do. Remember that the double star is exponentiation. Okay, now remember our question. It was abate dfac of 0.4. What's the duration? It was 1. It was 9,000, and got 5,400 as we thought. Excellent. Okay. So let's summarize. We've looked at the concept of discount, which we've seen through all these function definitions is dual, if you like, the mirror image of the concept of interest. And we've sort of seen how as the interest functions allow us to accumulate money or amounts, the discount functions allow us to decrease. Now in our next time we'll look at the relationship more deeper into the relationship between interest and discount. But until then, goodbye and God bless.